Hello students, the topic that we are going to discuss here is called early calculus. We are going to study calculus by breaking it into 10 simple steps. Now what is calculus? Calculus is a branch of mathematics which is a necessary and essential part to study higher level physics. Isaac Newton, a renowned scientist and a mathematician, and Leibniz, another mathematician, are called fathers of calculus because they developed this subject independently. Newton used his works on calculus to develop his laws of motion and gravity. So you can understand how important this subject is. Calculus is divided into two subjects, that is differential calculus and integral calculus. Differential calculus is used to find rate of change of physical quantities and maximum and minimum values of functions. Integral calculus is used in calculation of areas and volumes. So let us begin a small journey of this vast topic called calculus. So let us begin with differential calculus. Now you would have frequently heard the word operators or operations in maths. To give you a simple example, square root. Square root is an operator. For example, if we get somewhere square root of 25, now we know square root of 25 is 5. Now there are two things here. First thing is we should recognize what symbol is this, or we should know the meaning of this symbol. Second is we should know square root of 25 as 5 by heart. Now somewhere if in calculations we obtain square root of 144, we write it as 12 because we have by hearted square root of 144 as 12. In fact, any student who does not recognize this symbol will not know what it is. And second, if we don't know square root of 144 by heart, to write 12 is not possible. Now similarly, when we come to differentiation or when we come to differential calculus, so when we talk about differential calculus, in higher level maths, there is an operator associated with this. So there is an operator associated with differential calculus, just like square root. So now what is that operator? What is the symbol and how it acts on functions? We are going to discuss now in detail. Now we talk about differentiation or finding derivatives of algebraic functions. Now let us consider an algebraic function of the form y is equal to a into x power b. So this is an example for an algebraic function. In this, a is called coefficient. So a is called coefficient or it is called just constant. So a is called coefficient of x power b. So this is called, in short, we call it as coefficient. Then this x is called the variable. So x is called variable and this b is called power or it is called exponent. So now let us see how to carry out the differentiation of such kind of a function. Now when we say differentiation, differentiation is usually done with respect to the variable. So therefore we say technical language that we use is we are going to find the derivative of y is equal to a x power b with respect to x. So that is how we say. So differentiation is always mentioned with respect to the variable. Yes. So now how to get the derivative of this? Now if you have again this function y is equal to a into x power b, the derivative of this function a x power b is denoted by the symbol d by dx, which as I said it is called d, that is called derivative with respect to, is denoted like this with respect to x, that is it is denoted as d by dx. So as I said students, this is an operator. just like how you have square root. So like that d by dx is a operator, and we say just like square root acts on number like square root of 25, this d by dx will act on this. So d by dx of ax power b. So we say the derivative of ax power b with respect to x. This is how we say it, and for this there is a method, there is a formula. So what is d by dx of ax power b? It's very simple. First what you have to do is you have to write the power. So you have to just write the power b as it is. Then you have to write this constant, that is a, as it is, into x power. The power should be reduced by 1. So that is b minus 1. So we say derivative of ax power b with respect to x is b into a into x power b minus 1. So this is how we represent the derivative. To take a simple example, let us say if we have d by dx of 2x power 7. Suppose I want to find derivative of 2x power 7. As I said, so here if you want, in the beginning you can write the details. Here a is 2, b is 7, and therefore the formula is first you have to write b or a, anything. So b will write, that is 7, into will write a, that is 2, into x power b minus 1. So b is 7, so this will be 7 minus 1. Therefore the answer for the derivative of 2x power 7 will be 7 into 2, that is 14, into x power 7 minus 1 is 6. So this is the answer, 14x power 6. Now let us make this topic more and more clear by taking some examples. Now let us go to example 1. Here the function is y is equal to 5x power 4. So let us find the derivative of y is equal to 5x power 4 with respect to x. Now after this, students, with respect to will be written as WRT in short throughout this book. Okay. Now let us see how to find the derivative of y equal to 5x power 4 with respect to x. That is, we have to find d by dx of 5x power 4. This is the way to write derivative of 5x power 4 with respect to x. So d by dx of 5x power 4. Now as you know, there is a formula for this. D by dx of ax power b is nothing but the power b into the constant a into x power b minus 1. So this is how you write it. And now here the value of a is 5, the value of b is 4. So if you substitute here, now first we have to write b, that is 4, into, then we have to write a, that is 5, into x power b minus 1. So b is 4. So therefore this is 4 minus 1. So therefore this will be 20 x power 3. So therefore we say derivative of 5x power 4 with respect to x is 20x cube. Example 2. Find the derivative of y is equal to 3x power 9 with respect to x. So let us compare y equal to 3x power 9 with y is equal to a into x power b. So we'll consider the values as a 3, b 9. Now we have the formula d by dx of ax power b is given by b into a into x power b minus 1. So therefore, d by dx of 3x power 9 is b, that is 9, into a, that is 3, into x power b minus 1, that is 9 minus 1. So 9 3s are 27, x power 8. So this is the answer for the derivative of 3x power 9. Example 3. Find the derivative d by du of u power 8 with respect to u. So you can notice a very small difference, that is the variable x is replaced by variable u. So that does not matter. We carry out the same differentiation or the same differentiation formula by taking x as u. So therefore, basically we write d by dx of a into x power b. So now we will just write it as d by du of a into u power b, and the formula is same. It is the power, that is b, into coefficient, that is a, into u power b minus 1. So now let us try to differentiate this d by du of u power 8. Now when the constant is not seen here, you have to take the constant as 1. So this is d by du of 1 into u power 8, because we know u power 8 can be written as 1 into u power 8. So therefore here a is 1 and b is 8, and according to this formula it is b, that is 8, into a 1 into u power b minus 1, that is 8 minus 1. Hence we get the answer here as 8 into u power 7. So this is the derivative of u power 8 with respect to u, that is 8 u power 7. Now let us consider the function y is equal to 5 by x power 4. Now suppose we want to differentiate this function. We want to find the derivative of 5 by x power 4. You can convert it into y is equal to a x power b very easily by writing this as y is equal to 5 into, now when this x power 4 is written on the top, it will become x power minus 4. So this is by the theory of indices. Now you can compare this with y is equal to a x power b. So if you compare with y is equal to a into x power b, here we get the value of a as 5, the value of b is minus 4, and therefore we have d by dx of a x power b is power b into coefficient or constant a into x power b minus 1. So therefore d by dx of 5 into x power minus 4 is, so first we have to write b, so that is minus 4 into a, that is 5, into x power b, that is minus 4 minus 1. So minus 4 into 5 is minus 20 into x power minus 5. So this can also be written as minus 20. Now if you take x power minus 5 to the denominator, you can write it as x power 5. So therefore in cases in which the x power is in the denominator, mathematically or algebraically you can take it to the top, convert it into ax power b, and then you can use the same formula to find the derivative. Now consider the function y is equal to 7 square root of x. Now we will rewrite this function as y is equal to 7 into, now root x can be written as x power 1 by 2. Now this is of the form y is equal to ax power b. So we will compare with y is equal to a into x power b. So here the value of a is 7, the value of b is 1 by 2. So therefore we have the formula d by dx of a into x power b is equal to b into a into x power b minus 1. So therefore d by dx of 7 into x power 1 by 2 is equal to, now first we have to write b, that is 1 by 2, into, then we have to write a, that is 7, into x power b, that is 1 by 2 minus 1. So this is 7 by 2 into x power 1 by 2 minus 1 is minus 1 by 2. So this is 7 by 2 into, now x power minus 1 by 2 can be written as 1 by x power 1 by 2. This is equal to 7 divided by 2 into x power 1 by 2 can be written as root x. So the derivative of 7 root x is 7 by 2 root x. So when there is a fractional power, the same rule can be applied to get the derivatives of functions. When we work out problems here, we get problems on exponents. So we should know the important rules of exponents. So some of them are, the first one, x power p into x power q is equal to x power p plus q. Second one, x power p divided by x power q is equal to x power p minus q. Third one, x power p power q is equal to x power p into q. Fourth one, ax whole power p is equal to a power p into x power p. Fifth one, square root of ax can be written as square root of a into square root of x, which can be further written as a power half into x power half. And the sixth one, x power 0 is equal to 1. Now let us say we want to differentiate something like a number 10. We want to differentiate 10. Now how to do this? Now already we have studied d by dx of a into x power b is equal to a into the power b into x power, the power is decreased by 1, that is b minus 1. Now using this, can we differentiate 10? Now the first question is 10 of the form a x power b? Now if you see this clearly, d by dx of 10 can be written as d by dx of, now this 10 can be written as 10 into 1. Now by the law of exponents, 1 can also be written as x power 0. So therefore this can be written as d by dx of 10 into x power 0. Now this is of the form same here, d by dx of a x power b. So this is d by dx of a into x power b. Now according to this formula, we write 10 as it is, then we write the power b, that is 0, into x power 0 minus 1, and therefore 10 into 0 is 0 and 0 into x power minus 1. Now 0 into anything, we know it is basically 0. So we get 0. So students, you have to remember that differentiation of a pure number is always 0. For example, suppose you get something like this, d by dx of 75, the answer is immediately 0. Similarly, if I get something like d by dx of 52, the answer is 0. Suppose I get d by dx of 125 plus 10 power 3. Now this 125 and 10 power 3 are pure numbers, so whatever it is, the derivative will be 0. So therefore students, here you have to always remember derivative of any constant. So a pure number like this is also called constant. So derivative of constant is always 0. So this has to be used in problems. Now suppose we want to differentiate a expression something like this, 9x square minus 14x plus 3. Now this expression is directly not of the form ax power b. That is, what I mean to say is, there is minus and plus sign between the terms. In these cases, what we do is, we individually differentiate the terms or we individually differentiate the functions. So we need to remember that suppose we have something like d by dx of y1 plus y2 plus y3 etc. up to yn, then we can write this as d by dx of y1 plus d by dx of y2 plus d by dx of y3 so on d by dx of y suffix n. So this is how we perform the differentiation. Now let us go to this question, d by dx of 9x square minus 14x plus 3 can be written as d by dx of 9x square minus d by dx of 14x. You can do it like this, or also you can make this plus and write minus sign inside. So you can also write it as d by dx of minus 14x. So this also can be written plus d by dx of 3. Now if you look at the first term, this is of the form a into x power b. So therefore we write this a into the power, that is 2 into x power 2 minus 1 plus d by dx of minus 14x. Now this is power 1 here. So this is a is minus 14, x power b is 1. So we write minus 14, that is we write a into x power, we reduce the power by 1, that is 1 minus 1 plus derivative of 3. Now we have seen recently that the derivative of a constant is 0. So we get 0. So therefore this 9 into 2 is 18. So we will get 18x, then minus into plus is minus 14 into, this is x power 0, which is 1. So therefore the answer to this question will be 18x minus 14. Now let us take another example for more clear understanding. Now let us say we want to differentiate d by dx of 10x power 5 plus 14x square plus 12x plus 9. So now we can see there is plus sign between the terms. So therefore, we can do it the same way. We can individually differentiate, that is d by dx of 10x power 5 plus d by dx of 14x square plus d by dx of 12x plus d by dx of 9. So now let us do this one by one. So now d by dx of 10x power 5. Now this is of the form a x power b. So we write a, that is 10, into the power, that is 5, into x power, reduce the power by 1, this is 5 minus 1, that is 50 x power 4. Next, we will find the second term, that is d by dx of 14x square. This is a x power b. So we write 14 as it is, then we write the power, that is 2, into x power, reduce the power by 1, that is 2 minus 1. So 14 into 2 is 28. This is x power 2 minus 1, that is x power 1, which is x itself. Next, we will differentiate 12x. So d by dx of 12x. Now we can treat this x as x power 1, so that this is of the form a x power b. So we write the coefficient 12, we write the power, that is 1, into x power, reduce the power by 1. So you will get 12 into x power 0. Now since x power 0 is 1, so the answer is just 12. So therefore, the answer to our question d by dx of 10x power 5 plus 14x square plus 12x plus 9 is here 50x power 4 plus 28x plus 12. So this is the final answer to the question. Now let us go to exercise 1, d by dx of 3x power 5. So we will answer this question, d by dx of 3x power 5. So now we know the formula, or we know the concept, d by dx of a x power b is given by a into the power b into x power b minus 1. So let us use it here. So here we can see the value of a is 3, the value of b is 5. So therefore, this is equal to a, that is 3, into b, that is 5, into x power 5 minus 1. So therefore, this answer is 15 into x power 4. Similarly, we will answer the second, d by dt of 10 by t. Now this can be written as d by dt of 10 into, now according to the theory of indices, 1 by t can be written as t power minus 1. Now this is of the form a x power b. So we write a, that is 10 as it is, into, then we write b minus 1, into t power b minus 1, that is minus 1 minus 1. b is minus 1, so b minus 1. So 10 into minus 1 is minus 10 into t power minus 1 is minus 2. So this is minus 10 into t power minus 2 can be written as 1 by t power 2. So therefore, we can give this answer as minus 10 by t square. So this is the answer to the question. Now exercise 3, we will find d by dx of 5 divided by x square. So let us answer this question. So d by dx of 5 divided by x square can be written as d by dx of 5 1 by x square can be written as x power minus 2. Now we have the concept d by dx of a into x power b can be written as a into the power b into x power 1 less b minus 1. So here you can see the value of a is 5, the value of b is minus 2. So if you substitute a, that is 5, into b, that is minus 2, into x power b, that is minus 2 minus 1. So 5 into minus 2 is minus 10 into x power minus 3. This is minus 10 into x power minus 3 can be written as 1 by x cube. So therefore we get minus 10 divided by x cube. So this is the answer to this question. Next, we will answer the next question. D by dx of 9 into x power 5 by 3. Now here this is already of the form a x power b. So here the value of a is 9, the value of b is 5 by 3. So let us substitute here, and it is a, that is 9, into b, that is 5 by 3, into x power b, that is 5 by 3, minus 1, minus 1. So here 3 can be cancelled with 9 3 times. So 3 into 5 is 15 into x power. If you take the common denominator here, 3 and 1, the common denominator is 3. So 1 into 5 is 5, minus 3 into 1 is 3. So this is 15 into x power 2 by 3. So this will be the answer to this question. Exercise 5, d by dx of x power 10 by 3 divided by 24. So let us go to answer this question. D by dx of x power 10 by 3 divided by 24 can be written as d by dx of, this is 1 by 24 into x power 10 by 3, and this is a x power, this is b, and we now have the concept here d by dx of a x power b is a into b into x power b minus 1. So let us substitute, this is a, that is 1 by 24, into b, that is 10 by 3, into x power b, that is 10 by 3, minus 1. So here you can cancel 2 5 times, 2 12 times. So you will get 5 by 36. into x power. So if you take a common denominator here, the common denominator is 3. So this is 10 minus 3. So this answer comes 5 by 36 into x power 7 by 3. Next, d by dt of square root of 10 into t. Now we can write this as d by dt of square root of 10 into square root of t. This is d by dt of square root of 10 into square root of t can be written as t power 1 by 2. Now this is of the form a x power b. So we will write a as it is, that is root 10, into b, that is half as it is, into t power b minus 1. So it is 1 by 2 minus 1. So this is root 10 by 2 into t power. Now we know 1 by 2 minus 1 is minus 1 by 2. So this is root 10 by 2 into t power minus 1 by 2 can be written as 1 by t power 1 by 2 by the theory of indices. So this is root 10 divided by 2 into 1 by, now t power half can also be written as root t. So therefore the answer to this question is root 10 divided by 2 root t, and this is the final answer for this question. Exercise 7, d by dx of 6x cube minus 4x square plus 2x plus 5. Since there is minus and plus sign between the terms, we will individually differentiate this. So this can be written as d by dx of 6x power 3 plus d by dx of minus 4x square plus d by dx of 2x plus d by dx of 5. So now the concept d by dx of a x power b is b into a into x power b minus 1. So now we will differentiate this one by one. D by dx of 6x cube. Now this is on the form a x power b. So we write a into the power b into x power. We will reduce this by 1, 3 minus 1. So therefore this is 18 into x power 2. Next, d by dx of minus 4x square. This is equal to, this is again of the form a x power b. So we will write minus 4 into 2 into x power 2 minus 1. Minus 4 into 2 is minus 8 into x power, this is 1. So this is minus 8x. Next, d by dx of 2 into x. Now this is of the form 2 into x power 1, a x power b. So this is 2 into the power 1 into x power b minus 1. So this is 2 into x power 0. So we get 2 into 1, which is equal to 2. And finally d by dx of 5. Now since 5 is a complete constant, d by dx is 0. So therefore d by dx of 6x cube minus 4x square plus 2x plus 5 will be equal to 18x square minus 8x plus 2. Hence the answer. Exercise 8, d by dx of 4 cube root of x plus 12 root x plus 3x power 5 by 3 plus 2. Again there is plus sign between the terms, so we will individually differentiate, we will break the terms. So this is d by dx of 4 cube root of x. So this is the first term plus d by dx of 12 root x, the second term, plus d by dx of 3 into x power 5 by 3 plus d by dx of 2. So now let us find the differentiation of these one by one. Now again the concept, d by dx of a into x power b is equal to the power b into a into x power b minus 1. So let us go to the first term, d by dx of 4 cube root of x. Now this can be written as d by dx of 4 into x power cube root of x can be written as x power 1 by 3. Now this is of the form a x power b. So we can write it as 4 into 1 by 3 into x power 1 by 3 minus 1. So this is 4 into 1 by 3 into x power. So if you take the common denominator here, 3 and 1, common denominator is 3. So 1 into 1 is 1, 3 into 1 is 3. So therefore this will come out as 4 by 3 into x power 1 minus 3 minus 2 by 3. Next we will go to the derivative of 12 into root x. Now this can be written as d by dx of 12 into root x can be written as x power 1 by 2. This is again a x power b. So we will write a, that is 12, into b, that is 1 by 2, into x power b minus 1. So 1 by 2 minus 1. Here 2 cancels 6 times. So therefore this is 6 into x power 1 by 2 minus 1 is minus 1 by 2. Next, d by dx of 3x power 5 by 3. This is again of the form a x power b. So therefore this can be written as a, that is 3, into b, that is 5 by 3, into x power b minus 1, that is 5 by 3 minus 1. So here 3 cancels. So this is 5 into x power. If you take the common denominator here, that is 3. This is 5 minus 3. So this is 5 into x power 2 by 3. And finally d by dx of 2. Now since 2 is a complete constant, d by dx is 0. So therefore now we can write the answer to this question, d by dx of 4 cube root of x plus 12 root x plus 3x power 5 by 3 plus 2 will be equal to, here 4 by 3 x power minus 2 by 3 plus 6 into x power minus half can also be written as 1 by x power half, that is 1 by root x, plus 5 into x power 2 by 3, and the last term is 0. So, there is no need to write, hence we arrive at this answer. So, we just want to give a note here. Now, the equation y is equal to a x power b can also be written as, so you can also write this as f of x is equal to a x power b. So, instead of writing y, you can also write it as f of x, where we say that this is a function of x. So, instead of writing y, you can say function of x a x power b. So, this x here indicates that this is the variable. So, always variable is written here. So, f of x is equal to a x power b. For example, we can write f of x is equal to 3x square, f of x is equal to 4x cube. Now, if the variable is different, for example, let us say if the variable is something like t, so then we write f of t is equal to 4t cube. Yeah, so here t is the variable, so therefore it is written as f of t. So this is one notation for writing the function. So instead of y, you can write it as f of x. Now, you know derivative of y is written as d by dx of y, or it is written as d by dx of a x power b. So, we have been using it conveniently in many problems now. So, now if the function is represented as f of x, the derivative is written as f dash of x. So, this is the way to express the derivative if we call the function as f of x. So, sometimes we call it as f dash of x, or some call it as f prime of x. So, you can say f dash of x, or this is how we read it, or we can also say f prime of x. So, therefore, if f of x is equal to a into x power b, then we say f prime of x or f dash of x is equal to same thing, that is a into b into x power b minus 1. So, this is another way, that is f dash of x is just another way to write d by dx of y. So, we write it as f dash of x.